Everyone. Today we're going to show you the one of the most popular vulnerability attack in smart contract, the so-called reentrancy attack. So the reentrancy attack basically have two. Typically, we have the deposit and withdraw account, smart contract. So this is a very simple smart contract in which you can deposit some money into this smart contract, and then you can withdraw it, and you can also get a balance. So nothing surprising, but this withdrawal is vulnerable to the reentrancy attack because over here, what we do is we check how much amount we have in the balance, and then we try to use this function to send all the money. And so we basically withdraw all the money from here, and then we set to 0. So logically, there's no issue, right? If you have $10, you withdraw $10. If you have $20, you withdraw $20. But the issue is if the withdrawal is called from another contract, that contract is able to call withdraw again before the first call is finished. So in other words, before line 19 is set to 0. So before line 19 is set to 0, this is called again. So it's going to drain the balance in the smart contract. So that means instead of just call once, and suppose you have balance of 10, instead of just withdraw 10, you're able to withdraw 10, withdraw 10, withdraw 10. So it's going to be over withdrawal from the individual account. So let's see how that happens. I already usually mix to compare both contract. So this is a tag contract over here. The tag contract basically is trying to create an interface for that. For the first account, I call iBank. Basically, we just expose the two functions, deposit withdraw from the early over here, deposit withdraw. I don't care about bad balance. And then the constructor is trying to initialize the this my bank to the first contract. So the first contract address over here. In addition, I record the owner, which is basically whoever deployed this smart contract, so that we can send the money there later once we have a successful attack. So this is attack function. Basically, what you do is you deposit maybe, for example, 10 Ethereum, but you're able to call withdraw over here. Not just once, because the moment you call withdraw, you're going to have a call. This is so-called callback function. The callback function is going to be called automatically whenever this smart contract, the second smart contract receive Ethereum. So whenever you call deposit over here and call withdraw, go back over here. So this job is going to be called, and then line 18 is going to be called. Whenever line 18 is going to be called, the attacker is going to receive some Ethereum. So that leads the call of receive automatically, like a trigger. And this trigger, what it's going to do is, as you can see, it's going to call withdraw again if the balance is greater than 0. Look over here, when we check the balance, we are not checking individual balance. We are checking the whole, we are checking the balance for the first smart contract. So the balance for the whole thing, okay, for this contract. So that's going to be a lot of, so you're going to basically drain the whole account, including other people's Ethereum in the smart contract. Okay. So this withdrawal is going to call, and then that leads to the second call withdraw, and then again it's going to send again the 10, because the balance is still 10. We didn't do line 19 yet, so it's going to be called this 19 over here. Check this and call that transaction from the send Ethereum to attack again. So attack is going to call withdraw again. So line 26 is going to be called again like a loop until all drain out until the balance is either equal to zero or even smaller. I don't think it's possible to be smaller. But then we are going to have, and then we are going to use this to transfer all the money from the smart contract to the deployer, whoever deployed this. Okay. So in this experiment, I already have done some experiment, so we're going to continue to do it. So here we have 10 account. This is all the other account is 100. So why don't we use these two accounts to do some deposit? Let's deposit 90 and 90 from each one, so that only 10 is going to remain. So we're going to choose this one. Okay, and then going to say deposit 90. Okay, let's say 90 is going to be 18.0. 18.0 over here. I call deposit. As you can see now, the balance, this balance for the whole smart contract. Okay, the total. Okay, so but if I want to get individual balance for the current account, it's also going to be 90 as well. So this is 90 plus 18.0 because that's the number of decimals. And then if you look at the this, now this account only have 9.9 because we also use a slightly guess. Let me try this one also. This one, why don't we, instead of 90, I'm going to use 80. One. So if I deposit again, you can imagine 80 plus 90 is going to be 170, and the balance for the individual is going to be 80 plus 18.0. So now we have 170 for the total. So let's say we have the attack. I use the first one as attack. Remember, we have 279 already over here. So this address, the first account is going to be the owner. Also, who deploy the attack. So over here, and obviously right now I didn't do any deposit, so this guy is going to be 0. But now I could, we deposit 10 over here. You call the attack, so deposit 10 and withdraw 10. But because of the way reentrance work, it's going to allow me to withdraw more than 10. It's going to allow me to withdraw 10, 10, 10, 10 until you know. Okay, so I'm going to call the attack using the 10 Ethereum over here. So I'm going to come here and say attack, and as you can see, instead of withdraw 10, I withdraw 70 already, and this 70 is in the smart contract. I didn't call line 28 yet. The reason why is because I didn't drain yet. I still have 110 over here. I can drain it, and right now, let me see the balance over here. Of course, balance is 0, but I can deposit over again. Deposit another 10. Okay, deposit this. So then I'm gonna do another tag. This time maybe I can drain all of this, but maybe not. I don't know how many attack I need. But this will, let's see, attack. Okay, so I did attack successfully. So now this becomes 0. And now why this becomes 0? Because once that becomes 0, this line is not going to be true anymore. So the else part is going to be executed, meaning we're going to send all the Ethereum from the second smart contract to the owner, which is account 1. So if you look at account 1 now, I have so many Ethereum, 449. So I successfully have the reentrancy attack and then drain all the money from the bank, including other people's money, and then able to gain so much. So as you can see, we didn't do too much uh, stuff over here, but we are able to do the re-entrance very successfully. So thank you so much, and have a nice day.